Well, hi guys. Today our expert is Roman Nevolin. He is a developer of different bioinformatics, chemistry, or finance-related applications in C# and F#. Well, I speak F#, so you understand that he's an expert in functional programming. Also, he is experienced speaker. It's his 20th conference now, and he is a member of .next programming committee. Hi, Roman.
Hi everyone. Hi, I'm really happy to welcome you to this talk because it's quite a great topic, interesting for, I guess, mostly everyone who don't like all these games, programming games and so on.
Okay, great, thank you. And our speaker today is Roman Yosifovich. He has come to .next
Actually, no.
.next already, and he was talking about internals. But right now he has switched to this topic, to games. So also he is an author of several books and experienced speaker and blogger and mainly developer. Hi, Pavel.
Hi,
Well,
how are you?
Great, thank you. Glad to see you here on .next.
Yeah, happy to be here. Well, I
Okay.
mean there, but here.
Okay, welcome next time in St. Petersburg. Okay, and I just wanted to ask you, why did you decide to switch topics in such a dramatical way?
Well, I'm not sure it's actually switching. I did write games when I was younger, but I mean, games are fun. Every other topic we typically work on is maybe something more serious, like Windows internal stuff and cybersecurity and databases. That's nice, but sometimes you just have to have some fun. And when I started with computers, I actually was fascinated by games. And I was writing some games when I was a teenager. And I decided, well, why not do it again?
By the way, in the same time, it is fun, but it is one of the most serious topics I know, just because there's plenty of things you have to think about, like how the internals or the performance or the very, very different topics like sound, like graphics and so on, and also just game mechanics. It's quite a hard logic you have to program, so it's quite interesting to hear.
Okay.
Yeah, I think so. It's I think game programming is like taking everything together and trying to build something. And at least you can see something on the screen. I mean, sometimes you work and write to a database or do some algorithmic work, but you see nothing. I mean, just see your own code, but you don't see anything kind of interesting moving on the screen. So games kind of give you something to create. And I like that part in the game.
Okay, just wanted to ask Roman, so did you have experience in writing games? Were you one of the guys who wanted to become a developer for writing games?
I guess the first book I read about programming, oh no, the second book I read about programming was a book that really told about programming in a sample of making games. So game was one of the first things I actually wrote, and it was quite fun. But then it was with any programmer, when at the beginning you thought like, oh, okay, I am gonna make cool games, and then you finish in here making business applications and so on, which could be fun, but in kind of different way. So.
Okay, I understand you. Okay, Pavel, and who is the main audience for your talk?
Well, it's about writing 2D games for in C# using the MonoGame framework. So any C#.NET developer that wants to get a nice introduction to how to write games, especially using the MonoGame framework, is perfect for this talk.
Okay, great. So I think it's great time to start.
All right. So hello, everyone. Thank you for joining me for this talk about building a cross-platform 2D game with MonoGame and C#. So the idea here is that games are fun. I mean, I like playing some games, mostly not of all those complex games we have today, but simpler games like the old days, the 80s, maybe early 90s. And so I decided to show you how to write a 2D game using MonoGame and see the main components of building a game. Now, I'm a developer, I'm a trainer, author, I've written a few books. None of them is about game programming, although I did want to do that at some point in time, and maybe I'll do that again. I have some courses I have on Pluralsight and Pentester Academy. I have some open source tools that I created, and you can find them on my GitHub repository. And I have a website where I mostly use it to host my blogs. And so what I'm going to talk about, we'll start with what MonoGame is. I mean, what is MonoGame? Why would we even want to use that? Is that something we want to use? And then hopefully you'll be convinced that there's something interesting about MonoGame, and we can start using that by creating a new project that's going to be a game. We're going to focus on 2D games because 2D games are generally much simpler than 3D games, but it doesn't mean they necessarily have to be simple or boring. They can be very, very interesting. But we're going to focus on 2D only because really this is the fundamentals of writing games. And then we'll discuss assets. So how do you use bitmaps and sounds, and how do you get those into your game using, of course, MonoGame. We'll discuss the very important concept of sprites. This is how you actually have these moving objects in the game. How do you create them? How do you move them? How do you animate them? And of course, specifically, we're going to look at that from the MonoGame perspective. We'll discuss some aspects of game logic. I mean, you have something's going on in the game. There is usually a player that you need to control. This is where the human part comes in, but then there are other aspects of the game, maybe some enemies, maybe some other things happening in the background. So you must have some game logic and how to do that, how to prepare to work around that when you need to. And of course, we need to look at sound a little bit, because if you try to take your favorite game and play it without sound, you'll find that you lose a lot of the appeal of the game. Sound is actually very important. So we'll see how relatively easy it is to use sound using MonoGame. We'll discuss then game statistics. So you want to see in which level you are, perhaps. How many lives do you have? Shield, power, score, whatever is relevant for the game. We need to be able to display that in some way, and we'll discuss that. And perhaps some other small aspects, or maybe big aspects, but at least give you some intro to what to go, where to go next, and some other aspects of games that, of course, we won't be able to cover everything in this short talk. So that's the basic idea. So let's begin. We'll start by what is MonoGame really? So MonoGame is a cross-platform .NET-based game engine. And so today, if you're familiar with the game development landscape, you know there are so many game engines today, so many frameworks you can use to build games. Some of them are relatively small, some of them are really big. So many of you are probably familiar with Unity 3D, which is very popular, but this is kind of a monstrosity where you actually work with some graphical user interface to build aspects of what you're trying to do, like a game, and then you add some scripting in C# or JavaScript to do these kinds of changes or dynamics in the game. But if you're just a developer and just want to write code, then you need something simpler, something which gives you a class library you can build upon, not necessarily a full game engine. So MonoGame is exactly like that. You can start very quickly, as you'll see in a moment, without having to learn a lot about some maybe very complex thing. And so the MonoGame framework is actually built on top, or maybe mimics, the XNA framework. You might be familiar with the XNA framework that Microsoft created about 10 or even more years ago. And that framework was actually very, very nice and easy to use. It was a .NET framework, but it only targeted Windows and later on Windows Phone as well. And so MonoGame took XNA framework and made it bigger by supporting more devices and more platforms. That's why it is cross-platform today. Microsoft stopped supporting XNA, but MonoGame took that same object model and moved it forward. So if you know XNA, by the way, then you also already know most of what you need to know for MonoGame. So that's also very nice if you had that kind of background. But even if you don't, you'll see that it's relatively easy to get started with MonoGame. So why would you want to use MonoGame? I think it's because you don't have a very steep learning curve. You can just create a new project, and you're good to go. There are also some nice samples on the MonoGame GitHub repository, and people are posting tutorials, and it's a fairly stable framework to use. If you want to do something much more complex than that, then maybe perhaps you need a full-blown game engine. You need something which is more than just a framework. You can get something bigger if you go to Unity or Unreal Engine, these kinds of monstrosities. They have much more functionality, but the learning curve is also more steep, and it's less programming. It's more like working with a tool. So I'm a developer, I like to write code, and that's why MonoGame appeals to me, but definitely not the only option. There are actually so many frameworks today, and you are free to explore all that crazy world of game development. Okay, so what are we going to build? This is something like a screenshot from what we're going to build. This is a very simple, like Invader-style game with some extras. And the idea is to create something relatively simple that everyone can relate to. I'm not saying it's the greatest game in the world. It's not. It still requires lots of work. And I'll discuss some of the aspects that are important to understand when building a game, because the game is not just about the graphics. You can have really great graphics in a game, but the game could just not be fun. I mean, making a game fun is an art into itself, which is not part of this talk. We're going to focus on the technical aspects of creating a game rather than other more design-like aspects of the game, which is a very important part, but it's not really that much relevant for C# or .NET. It's more generic. So let's start with MonoGame. How do we do that? The first thing is to install MonoGame. That's kind of obvious. So the best way is to go to the MonoGame website and then download the project templates. That would give you a head start by using the normal File New Project in Visual Studio. The alternative is to use the NuGet packages in order to get the assemblies for MonoGame once you start writing, but I find it easier to start with the templates. I'll show you that in a moment. And what you'll find is you have a set of projects you can select from when you create a new project, and you can do that in two ways. One way is just to select some platform you want to target, like Windows or Linux or Android, and just go ahead and write your game. The other option is to start with a .NET standard library that uses MonoGame or a shared library project and put everything in there that is really common to the game, and only add specific projects with just the startup code for the particular platform. In fact, this is fairly easy to do. So you can actually target multiple platforms using the exact same code base, except for that main function that might be a bit different from platform to platform, but it's not your focus. Your focus is the shared library where you have most of your code. Okay, and here's a link for you. You can look at that later, how to get started, all the instructions that you need to do in order to install all the stuff you need for MonoGame. So let's see what that looks like when we use Visual Studio. So here's Visual Studio. I'm doing Find New Project. I've already installed all the project templates, and you can see here there's a bunch of templates here related to MonoGame. I just need to select the one that I want to start with. So that's Visual Studio 2019, and I'm using here the new project dialog. Then you might think that this is perhaps a bit weird, because Visual Studio 2019 has this new project dialog which looks different, and it's actually pretty terrible. I really hate it. And so fortunately, someone in the community wrote an extension that brings back the new project dialog from the Visual Studio 2017 days. So I'm using that. So don't worry, I'm not using Visual Studio 2017, but just using the old dialog. So we can select here something like Desktop GL, which will give us a desktop application that is going to run on multiple platforms like Windows and Linux, where OpenGL is supported. There's some specific for Android and for UWP and so on, and of course for Windows. And we can go with the standard .NET standard library to host most of our code and assets there, and then just add new projects that to reference that library. So for simplicity, I'm going to start with a simple Windows DirectX application, but of course, you can start as the full game, the full implementation by using a shared library or .NET Standard library, and then just link to it another one or more projects for the actual game where the main function is. So I'm going to do that, and I can call that space.net. That's going to be the name of the game. So I can do something like this and click OK. And what we get is a simple project, a single project in this case, that's going to have some initial code for our game. So we'll see what that looks like once Visual Studio, of course, manages to come out of its coma. So here it is. Here's what we get. We have a main function like always. So here's the program.cs. Let's see what that looks like. As you can see, it's very, very small. There's nothing like creating a class, an instance of game1, which is this class created for us already by the wizard, and then using the run method. That's it. This is all what we need in main in terms of Windows. If you look at other project types, you'll see a bit different main, but we don't really care about main. I'm not going to touch it. What we want to do is look at game1, which is the main class that derives from a game class that MonoGame provides. So even without doing anything, you can just go ahead and press Ctrl F5 to build that and run that and see what we get. So once it's built, here's what we get. This is it. Not very impressive, I know. We have some just a window with a particular color. Well, we have to start somewhere, I guess. So let's see what we have in terms of code. So first we have the game class. Now, of course, you probably don't want to leave that kind of name. So you can just make the change that you want, like space.net game, to change the name of the file and the class while you're at it. So here we have a better name now. And what we have here is the singleton object that is created in main, which is our game class. It currently has two members. One of them is called graphics of type graphics device manager, and something called a sprite batch, which I'll discuss later on. And then in the constructor, we can creating this graphics device manager object, doing some other initialization here, like whether you want to show the mouse or not. And then that's it. We have some initialize override, load content override, which we'll discuss. And we have two very important methods, update and draw. So draw actually is called every single frame. And by default, the game tries to run in 60 frames per second. However, we can actually configure that to something else if we wish. You can see here there's this clear method with the cornflower blue color. That's the color we've seen. That's the classic color from the samples back in the XNA days. So because it's going to be probably a space kind of game, so I can change that to black and then just go ahead and run that. And we get, we get a black empty screen. Again, something to start with. So if I do a little bit more work, here's another example which has a bit more code in it. I can change the window title. I can specify whether I want the game to run with full screen or not. I can specify the window size that I want, as you can see here with some numbers. And then I can call the apply changes to make that happen. So if I do that, I get something a bit different, that just the screen looks it's going to be a bit bigger because I want my game to run with a higher resolution. And I can specify full screen or not full screen, depending what I want. And in a kind of full-fledged game, it's probably going to be the selection for the user. The user can decide to run the game full screen or not. So you can see the new title for our game here. And I'm going to keep that in windowed mode because then there's going to be no flickering when going from Visual Studio to running the game. So that's kind of the first step. There's really nothing much to it. We have already a game window that we can use. Great, so now we can move to some more interesting aspects, but this is just how we get started. So what happens in a game? Think about a normal application, maybe a WinForms, WPF application. What's happening while the user is just looking at the window? And the answer is that nothing much. So nothing much is happening, and that's because the thread that manages the UI is waiting for user input. And if the user is doing nothing, then nothing interesting is happening, no CPU is being used, and that's it. That's usually the case with the classic user interface applications. However, in a game, there is no such thing. The game always sits in a game loop where 60 frames per second, 60 times per second, there is an update. And that update contains two main stages. One of them is the update stage. This is the update method we get in the game class, which we have to override. This is where all the logic updates happen. This is where I'm checking whether the player has pressed a certain key. This is where I update the state and position of enemies, of shots, of anything that is happening in the game. This is where I'm doing all the logic stuff. Of course, I don't have to write everything in that method. I can split that to different methods, use other objects and so on, but this is going to be called 60 times per second. And then, of course, we also have to draw the scene, to draw the actual things that we want to show. That's going to be in the override for the draw method. And again, that's going to be called 60 times per second. So normally, what we get is calls to update and draw in the frame rate that we have specified, which is 60 frames per second by default. So this is where the action is happening, and the CPU is never really idle. It's not really doing nothing, except in the case where you manage to render the frame before your time slice for the frame elapses. So if you're running with 60 frames per second, it means you have 16.67 something milliseconds to do everything. And if you manage to do that in less, then you might wait a little bit for the screen to refresh. But if not, then you're going to be running all the time. So this kind of game loop, this is something that every game has, is based on this frame per second or the frame rate you want your game to run on. Okay, so great. We understand the purpose of the game loop. So now we need to look at something called game assets. So game assets represents all the media that we're going to use in our game. It could be images. They're officially called textures in MonoGame. Not just MonoGame, but at least MonoGame. We're talking about the sound and music files, and we're talking about some other interesting things such as 3D models, which are not part of this talk, but generally if you are building a 3D game, then you have 3D models in some format that you need to use. These are assets. You have to load them at some point and then do something with them. Even fonts are assets, and this could be even other kind of data objects like XML data that perhaps describes levels in the game or enemies in the game or anything else that you might need. And so all these assets go through something called the MonoGame content pipeline that sort of compiles that to a different format with the file extension XMB, and these are the things you can load into your game. And it's fairly easy to do. So let's see what that looks like. So let's start with this option here. So currently what we have is just a black screen, not very interesting. So you can see that every project has this content.mgcb file. If I double click that, there's in fact a special editor for that that allows us to add assets. So it is configured once you properly install a MonoGame, but regardless, once you have that open, and apparently here it is, opening on my other screen here, you can see the content here. This is where you actually add your assets. So for example, I can create a folder here. Let's call that the backgrounds. Here it is. And then I can go ahead and add something that exists already, existing item. That's going to be the background for the game. So I have some content already sort of prepared beforehand. So let's go ahead and find them. So here it is. Here's the content. I have here some background for a space game. So I'm going to select that. And it says, maybe you want to copy that to the directory of the game. Yes, I do want to do that. So now we have this thing here, and now we can either build that from the tool, this editor, or simply continue building that normally from Visual Studio. So now that it's here, we need to load that background and do something with it. So to do that, I'm going to add a member here. That's going to be a texture 2D. Texture 2D represents a bitmap, really, or something like that, really a bitmap. So let's call that background. And then we have the override called load content. So load content is the override we need to use in order to load our assets. So of course, we don't have to do everything here, but this is going to be called automatically by the framework. So I can do something like background, and then I can do content. That's the property I get from the game class. And then there's a load here. And this is a generic load where I can load various types of content of assets. In this case, I want the texture 2D that I want. This is the thing I want to get, and I need to give it the path, the relative path to the entity that I've specified here in the editor. So it's going to be backgrounds and BG. So it's going to be something like this: backgrounds/BG. I don't need to specify any extension for that. That's going to be the XNB that's going to be created, that has been created as part of compilation. But now, if everything is okay, this instruction would work. Otherwise, I'll get an exception. So now I can actually use it. So to use it is something that we will look at in a moment in greater detail. But technically, here I am in my draw method, because the only way or the only location to draw something is in my draw method. This is what that is for. So I can go ahead and do the drawing after I'm clearing the screen. I'm going to use the sprite batch. So a sprite batch is actually an object that you might have noticed here being defined here and created later on here in load content. So the sprite batch is something that knows how to draw sprites, which I'll discuss in the next slide. But just let's do something really quick. We need to first call the begin method to sort of prepare the sprite batch for work, and then we can use the draw method to draw any sprite that we want. So in this case, we need to provide the texture, of course. We need to provide something we want to actually draw. And there are many overrides to draw. You can see there are seven overloads to the draw method. So there are many ways to sort of customize drawing. But for now, I'm going to do something very, very simple. And then I'll show you something a bit more complex. So I'm going to just go ahead and draw that from position 0, 0, for instance. If I look around, there is such an overload, and then I need to specify the color, which seems a bit weird. I mean, I have a bitmap. Why would I need to specify a color? So I'll explain that in a moment. For now, I'm going to write color.white, and then just close the sprite batch by calling the end method. So once I do that, hopefully everything would work okay. Let me press Ctrl F5 to run that. So this is what we get. We get the bitmap drawn onto my window. I haven't specified exactly the size on all these things. It is possible to customize, but it just has been drawn here from position 0, 0. That is the top left corner of the screen, or the window, if you will. And in fact, in this case, the clearing of the screen is really redundant. There's no need to do that. It's just a waste of time, because in any case, we're going to draw on the entire screen this particular bitmap, so don't actually need to, in this case, clear the display, which of course is fine. And again, we can run that if we wish and see the result that should be very similar. Okay, so in any case, once we have that running, we can see we have our screen. We need to move on. So in the same way, we can load many more assets, as many as we need. This could be more textures. For example, we'll have a player ship, so we have to load that texture as well, and then draw that as well. And I'll show you how to do that in the next few slides. So now we come to that thing called a sprite. So sprites have a very long sort of history. They've been very popular in the 80s, in the 8-bit days machines, especially with the Commodore 64 machine that I had as a teenager. And that machine supported hardware sprites, so you could actually have these objects that you could specify the way they look, and they had transparent pixels, and then you could move them around and do some effects with them without having to incur any real CPU activity, because it was done by some hardware chip that was part of the Commodore 64. Now today we have GPUs which are sort of doing these same things, and so sprites is a general term for objects that typically are moving and animating. So they might change their shape and they're moving around as needed. And so we need to create those because most games have these kinds of moving things. And so in terms of animation, the way animation works in 2D usually is by having multiple frames. Every frame, every image looks a bit different than the previous one. So if you run them in succession in a certain rate, you get the illusion of animation. So you need to, of course, prepare all these things. And this is typically done by using something called the Sprite Sheet. So a Sprite Sheet is a way to create a big bitmap that contains all the frames of a particular object for animation purposes. In some cases, you can even create a really big Sprite Sheet that contains multiple images with their various frames, so you can create multiple types of sprites from them. Regardless, to draw these kinds of sprites, really just the same as drawing that background we did just now by using the sprite batch draw command. And the sprite batch, when you give it something that has transparent pixels, it respects that. And you can do some other nice effects while you're drawing, such as rotating the sprite or scaling it, and some other aspects that I'll show in a moment. So sprites are really the heart of any 2D game. You can't have a 2D game without sprites. Even 3D games have sprites, but for 2D games, you really can't do anything interesting without them. Okay, so one thing that you might have been puzzled about in the previous example is that color that I'm specifying here. I mean, what does color right really mean? I mean, I'm drawing some bitmap. So this is known as a tint color. This allows us to change the colors of the image based on the RGB values of this color we're providing. So it's not really the color itself, it's the levels of R, G, and B. So here's an example here in the slides. So if I look at the player's ship, which we'll draw later on, so this is what it looks like when the tint color is white. That's RGB 255, so it's just the normal. You would think of that as the normal way of drawing the sprite, because this is, in fact, the original colors. This is what that looks like. However, we can do some tinting by making a change. So for example, I can provide the color to be RGB, where R is 255, but green and blue are 0. So now all the red power of the colors, original colors, show through, but the green and blue are not shown. Same goes for other options that you can see here. So this is gray. So technically that's gray in terms of if you actually drew that color, but we're not drawing that color, we're using that as a tint. So it actually gives us kind of a bit less emphasized shape. And here's completely green. Only the green channel goes through and all the others are 0. Here's the blue channel and all the others are 0 again. In this case, I'm taking the red and green channel. This is yellow, but in this case, it means we don't have any blue channels. So all the blue colors go away. And if I specify color.black, for instance, I get nothing. Everything just disappears because I don't give power to any of the colors. This means that if I go back to the previous example, if I do something like let's say green, I'm going to only see the green aspects of the background image. So you'll see something like this, because most of the other graphics that was there had the red and blue flavors, and now all these are gone, so we have only the green stuff. So this allows us to do some really nice effects without having to waste any memory, because it's the same bitmap, the same image. You don't have to do anything else. It's just there. We can just manipulate it. So that's very nice and very powerful. This is something that I didn't have in those old 8-bit days on my Commodore 64. So Sprite Sheet, as I said, this is a way to have multiple images that are part of the same shape, and only one of them is shown at a time. So here's an example you can see on the right. This is a ship with the burning something in the back burner, where we see those flames, the reddish flames, and they're not exactly the same. Every frame they change a little bit. So you need to create this set of frames, and then we need to just draw the current frame. We have to have some way of working with that in a sort of reasonable manner. So that, of course, means we want to create some class to encapsulate the functionality of a sprite, the ability to specify where do I want that to be drawn, in what size, what angle, what's the tint color. And these kinds of aspects lend themselves well to creating a sprite class that has all these capabilities, and also that sprite class should be able to perform animation by saying, hey, here's an image for you, and that image has, let's say, 10 frames, so please just understand those 10 frames, and here's your rate for animation. Every time I request the sprite to update itself, it's going to look at depending on the frame per second and the animation timing I specified, it's going to draw the next frame as needed and loop back to the first frame, which is the classic animation, but of course it could be other types of animation as well. So I'll show you an example of a sprite class in a moment. So normally you have to create those sprite sheets. There are tools to do that. There are some very powerful tools to create those sprite sheets easily. Of course, you can write your own. It's not that difficult to write a simple sprite packer that takes multiple images and creates a single image from those images in just the right spacing, so you can easily then extract that information when you're building your sprite. Here is an example of a free sprite packer you can use, which is a simple web page. You can just upload frames there, and with some little configuration, you can get nice sprite sheets. In fact, for this game, this is exactly what I did. But if you search around, you'll find some more powerful tools that have more features that you might find useful if you're going to be serious about writing games. So let's look at the sprites a little bit. So let me go to another demo here. Let's see where I get usage of sprites. So here we can see I have a few sprites here. Let me open the content window again. This is in the content file, but this time for the upgraded project, if you will. So you can see here I have these backgrounds that we've seen already. I also created a directory, sort of logical folder called sprites. And here I've created a few sprites that we're going to use. One of them is for the player, and one of them is the burner. So in fact, the player is going to be just a single frame with the ship that we've seen earlier, and the burner is going to have some animation. And of course, we can just right-click and open that in Explorer to see these things. So let me show you what that looks like. So here are the backgrounds, here are the sprites. Let me go into that directory, and you can see here that the player is just a single ship, but the burner is actually a sprite sheet. So this is a sprite sheet that contains a set of sprites that are not exactly, set of images that are not exactly the same, that we want to animate at a certain pace. And of course, you can look at these in various tools. Here's an example for that I'm using here is the very fairly well-known paint.net tool. Here it is. So here we can see the various frames. The only thing I have to make sure is that the size of each frame is the same. Otherwise, I'll get some bad movement of of the sprite once I draw it, so you have to make that work correctly. And this is why these sprite packers are important, because they allow you to do that without having to work very hard. The player is just a single ship. So once we have that, we can start to do something with it. So the first thing I want to do is to load the player texture. Here's the player texture, and I'm creating a sprite here. So the sprite here is a class I created for the purpose of this talk, and this sprite class is the one that provides the basic support for handling these types of objects. So for instance, every sprite always works with some texture, and it has some position, and there's an origin. The purpose of the origin is to specify where is the sort of center of the image. So when I say position, what do I mean? Is the position of the top left part of the image of the sprite, or maybe it's the top right, maybe it's the center? So you can actually customize that, and that's actually very useful. Now you also notice that because we're writing a game, we can cut a little bit some corners. So if you're writing .NET, you probably are never using fields as public fields. You always use properties to wrap these fields. And normally that's a good thing to do. However, when you're writing games, first you want to have the maximum performance that you can. And so properties might incur some extra overhead in some cases, especially in debug builds. But furthermore, vector2 here, these are just simple structures. These are value types. And when you have properties of value types, that's a messy, because you can't really set a certain member. You have to set the entire object. And if you are not familiar with that, I urge you to try it out. So I'm just going to cut some corners and just expose these as public fields. Then you can get to the X and Y of these objects directly without anything holding you back. And that's considered fine, because when you're writing a game, you want to be as efficient as possible, and sometimes you are allowed to cut corners, so it's okay. Don't tell your managers that I said that. So I'm trying to expose everything that I can as public fields rather than properties, unless there's a very good reason not to do that. So for example, if I want something to be read-only, then I'm going to perhaps expose that with a property so no one can change that directly, so I don't get some interesting errors. And because I have to change that not in the constructor, I can't use the read-only attribute for that. So here you can see I have a constructor taking the texture and the number of frames that this texture is supposed to hold in terms of animation. And I have my init texture here that kind of splits that image to rectangles. In this case, I'm actually assuming that the way this is built is exactly as we see here, as one long strip of images. Some people use that horizontally. In fact, vertically is more efficient because the memory for these pixels is adjacent, so it's a bit easier for the GPUs. I'm not saying it's super important these days, because GPUs are really, really powerful, so it's not that much of a challenge these days, but still I try to be as efficient as I can, so that's more efficient than doing things horizontally or maybe in some other crazy way. But of course, if I would build something more generic than that, I would perhaps create a more generic code. So I'm not saying this class is perfect, it is not, it's a starting point. And so the important parts here that I have here are the draw and update methods. These are supposed to be called by the main game loop. We've seen already there's an update method and a draw method. So update is about updating animations and updating the position of the sprite. If it has some velocity, which I allow the code to specify, then I need to move that sprite in the same direction as the velocity here. So it's another vector2 type of object. So it's a 2D vector. And the draw method is responsible naturally for drawing the sprite. So you can see I can specify, I use the position that is the current position of the sprite, the texture of course, and then I'm selecting the correct frame in the array of frames. Because remember, I might be doing animation here, so I need to select the correct frame to draw right now. Here's the tint color, the angle I can specify, the region, which is usually going to be the center of the sprite, scaling that I can do kind of automatically. Again, these are really nice bonuses without you having to lose any extra memory for creating extra shapes with various sizes. You don't really need to worry about that. GPUs do that without any adverse effects. And there's some other aspects here that you can specify, which I'm not going to cover here. So this is just one way. And I also check something here called state. So I'm managing something called the sprite state, which means that the sprite might be logically dead. And so I don't want to show a sprite that is logically dead, and explain why that could be a bit later when we discuss a little bit about performance in terms of games. So once I have the sprite class ready, and we'll look at perhaps some other aspects of this class a bit later, I can go ahead and use that to draw my player. So the first thing I do here is load the texture for the player. That's going to be here. And then I'm creating a sprite based on that texture. Because it has a single frame, I don't need to do anything interesting here in terms of animation. So it's going to have just one frame. And I can use a method I created that is going to just scale that to 90 pixels. Because all this scaling stuff is very important. You might have very high resolution images, which is of course nice, but you might have a constrained screen. So you don't want to display them in their original size. You want to usually just shrink them a little bit depending on the resolution you're running your game. So you have to actually make sure that you do that correctly. Otherwise, it's going to look very, very weird. So now I have some position which I'm going to place my sprite, my ship, when the game starts. And I'm just using some information based on the window property that gives me the dimensions and coordinates of the window, so I can plan accordingly. And then I need the burner. So that's the burner with the animation. So I'm loading that again, and then creating the sprite here. In this case, I have 10 frames for the burner, so I'm doing that. And I can also specify the frame per second animation. This is a property I created for the sprite class, and the scaling I want to do, and the initial position, which is going to be based on the player's position. So this is happening only once when load content is called, which is just once when the game starts. So now I need to do some stuff here to make it work. So update is still not something we're looking at just yet. I just want to draw the sprite at this point. So to do that, here's what I'm doing. I'm just calling player.draw. So that's the sprite object with the draw method. I provided the sprite batch, and it's going to draw that, and also draw the burner. That's it. So that's kind of the first step, where what we get is this. This is what we get. We get our background, and we get our ship. And now, because we haven't done anything in the update method, then we don't get any animation. So it's still now being called 60 times a second, but nothing is changing because we haven't done anything to tell the sprite to do something with relation to animation. So what I need to do here is go to the sprite here. In this case, we know that the player, but the player doesn't really do much in this point, but still, let's do that. I'm going to call update, and I'm going to provide something called the game time. So a game time is an object provided by MonoGame. And that object provides information about the time that has elapsed since the game started, and the time that elapsed since the previous frame where update was called, and the same goes for draw. And in fact, I'm using that in the sprite class to calculate correctly how much to move the sprite if it's moving, and how to refresh the animation, so the current frame for animation. So I'm going to take both that and call update for both of them, because I specify it's going to be supposed to run in 9 frames per second in terms of animation. I expect that hopefully to animate. So if you run that, hope for the best. Okay, still hoping it's going to run. Okay, so here it is. you can see now that the burner is animating. I'm not sure it's actually showing very well in streaming, but it does animate. You can, of course, test that later on. So now we have a ship that animates its burner without me having to work very hard. I just specified the animation frames per second and the number of frames that I have, so I can just change that if I want that to animate faster or slower. I can just make the changes. It's just a matter of keeping it something that looks realistic enough. So this is not very realistic. It looks, well, maybe it is. I don't know. I mean, it's a spaceship. How realistic could that be? But it's very easy to manipulate once you have the proper infrastructure, in this case, the Sprite class. Okay, moving on. What else? So as you can see here, what happens in this case is that, well, another thing that I want to show you before I move to the next slide, let's look at demo 4 here. So the only thing that I change here is the ability to take input from the user. Now, every game has to have some interaction with the user, otherwise it's going to be a very boring game. In fact, it's called a movie, but we don't want to create a movie here, we want to create a game. So we need to interact with the user. By default, when you create a new project in MonoGame, you get this kind of code that checks whether the gamepad back button is pressed or the escape button is pressed on the keyboard, and if that is the case, the exit method is called, which ends the game. Which is fine, we can use that, we can leave that for now, but then of course you'll have to create your own interactivity. So one way to do that is by using the keyboard. And of course, if you have other types of devices, and in a real game you would want to perhaps support multiple devices, also depends of course on the type of the game, what kind of interaction is more natural. In this case, I'm just using the keyboard to move the ship left or right, and using space later on to fire something. So you can see here I can call the keyboard getState method to get some information about the state of the keys, and then I can do some checks. If the left key is down, I'm going to change the velocity in the x direction to minus 250. That's 250 pixels per second. That's the thing here. This is the way it's calculated internally inside the Sprite class. And then if it's the right key, I'm going to use a positive value to move to the right. Otherwise, I'm not going to move at all. And I'm going to specify for the burner the same speed, the same velocity as the player. Otherwise, the ship will move, but the burner will stay in the same place, which is going to be very bad. So I have to update both of them so that they update correctly. The draw stuff here doesn't really change, doesn't need to change, because the draw is just doing the same thing, drawing these same two objects. So now I have this one, and I can move left or right using the keyboard, the two keys to move my ship. So the update method is the correct location where any game should add its interactivity with the user. Okay, so great. We have something now. We have something that seems to work. We can move our ship, which is nice. The next step is to look at some perhaps design aspects in terms of MonoGame. And one thing that MonoGame provides is called game components. And these game components provide a way to sort of separate things into more manageable pieces. For example, when we need to take care of the player, we have to take care of the movement of the player, of the burner. We have to then later on take care of shooting bullets at the enemies. So we don't want to cram everything inside the game class. So of course we can create our own class to do these things, and MonoGame provides us with a way to integrate those classes into the framework. And the way to do that is by deriving from game component. This is for components that don't have any visible aspects, they only have an update method. And then there's a drawable game component that derives from game component that also has a draw method. And then you derive that here, and whatever you're doing, you can add that component as part as into the game using the game.components property, and then the game class automatically will call update and draw for your components. So in this way, actually the main game class doesn't do much in the update and draw phases. It leaves everything, or at least most of the things, to the components. And it's also possible to enable and disable components very easily. So perhaps if you're just starting the game, you have the initial credits, the game title, where you allow the user to select options and you see some information. That would be a component. And then once the game starts running, you're going to disable that component or remove it and add another component which contains perhaps the enemies, and another component that manages the player, and so on. So you can work with these high-level objects and they integrate nicely into the framework, calling the same or similar methods as are available on the game class. So let's see what that looks like. So here's this is in fact the full game. The full game at this point. I'm going to just focus on sorry, this is not the full game, this is the full game. I'm going to focus on components here. So here are components. By the way, notice I have these two projects here. One of them is a shared project where most of my code is, and then I have a version for the Windows desktop, and I can create another version for Android. You can add another version for another type of device supported by MonoGame, and all these code doesn't really need to change. I only need that extra simple code for the particular main that is appropriate for that type of platform. So here you can see there is a components directory here, folder, and then I have several components. One of them, for example, is the player component. So the purpose of the player component is to encapsulate all the player functionality, but not just functionality, but also statistics. So for example, you can see there's a property for the score of the player right now, the number of lives that the player currently has, whether it has a shield active, what's the state of the player. Is it alive right now? Maybe it's exploding. It could have multiple states. And so every component must have a constructor that accepts the game object. So we have to call the base class with the game object, and that's it. And from now, we can just override initialize if you want to create new stuff, or load content in the load content override. Here I'm actually loading the player. Previously, I did that in the game class, but now I'm diverting that to the component. Same goes for the burner and the shield, which I haven't shown yet, the purpose of the shield, and also missiles that I'm going to use, and so on. So everything that's related to the player, I'm going to put here in that player component. Same goes for the draw and update. So draw here is going to draw all the missiles that I'll show you in a moment, the ship itself, the burner, the shield if it exists, and I do some other aspects of drawing here in the shield. In case of the shield is active, I'm actually drawing a bar indicating how much power is left for the shield. So anything related to drawing I have to do here in draw, and that draw is going to be called automatically by the draw method from the game class. So I just need to do whatever I need to do here, and same goes for update. So here's where I'm going to actually look at the player state and do some checking. So if it's alive, I'm going to look at the keyboard state and move the player accordingly. If it's pressing the space button, then I need to create a new missile that's going to be a shot at the enemies. So perhaps it's a good time to just show you what that game looks like. It's not really complete, but it's complete enough for our purposes. So you understand more about what I'm talking about here. So here it is. So already been decimated by that bullet. Let me try to do something maybe better here. So here here's some C# I can capture. Now I can fire much faster. So C# actually helps me in the game, which is very nice. I also can capture something else called the .NET Core. Here's a .NET Core that gives me a shield. Here's the shield. You can see the bar at the top indicating how much time I have protection from bullets by these enemies. Once I get all the enemies, I go to the next level. That's going to be a bit more difficult. And we have these asteroids flying around and some stars moving. So I know it's perhaps not showing perfectly because of streaming limitations, but you can try this out yourself. So this is what we have here, and you're welcome to extend that game if you wish. And at some point, of course, I might be completely blown away and I'll get a game over information here as the final screen here. Okay, so just to show you what that looks like, so essentially, once you have the basics at hand, you just continue adding more and more features. So in terms of missiles, for example, how would that work? There's a find missile here. So why do we need to find something? Why don't we just create a new sprite and just go ahead, initialize that to the correct position and velocity, and then let the update and draw methods do their thing? So the thing here is that one of the aspects that are obvious for a game, we want to have the game with high performance. So we don't want the game to be laggy. So you're probably familiar with the experience where you have a game, you kind of playing, and then suddenly something sort of looks choppy. Maybe the game is doing too much, maybe your computer is not powerful enough, whatever that may be. This is not really a nice I would say experience. So gamers don't like that. And because we're writing here in .NET, we're still constrained by whatever .NET has to offer us. And .NET, of course, has a garbage collector. Everybody knows about that. Some people like it, like Conrad. I'm sure Conrad would like to talk about the garbage collector all day long. However, we don't really like garbage collector to interfere with the game. So how can we make the garbage collector less of an interference? So how can you make garbage collector not work? The simple answer is don't allocate anything. If you don't allocate anything, the garbage collector has no reason to wake up. But of course, it's easier said than done. Can you really not allocate anything? Probably not. But you can really try your best. So what I'm doing here, instead of just creating new objects every time I need them, I'm creating them up front whenever a new level starts. So for instance, if you go here to the end here, you can see that I have an array here for example, the missiles themselves. So we have here an array of 10 missiles. I decided there can't be more than 10 missiles at the same time on the screen that the player is shooting. So I have this array and I'm creating these missiles up front. So all these sprites are ready to go before I actually start the level. So that means whenever I need a missile, I need to find a sprite within that array that is currently not being used. So it's currently like a dead missile. And that's why it's important to have that sprite state, because if it's dead, then I can use it. If it's not dead, then I can't really use it. So that's the idea. Everything I can create up front, I am creating up front. That would mean that the garbage collector has a very small chance of waking up. And even if it does, it's going to be a Gen 0 collection, which is very fast. So I'm not really worried about that. And that's a typical technique when working with managed environments where there's a garbage collector. You try to allocate everything up front, or at least most things up front, so the GC has no reason to wake up later on. And when you go to the next level, you can even do GC collect if you wish, and try to get rid of whatever garbage you have collected at that point. So when you start a new level, you are fresh. So that's the idea. Okay, so these are the game components. Let me show you another component before I move on. So another component is the star field component. This is where we see the stars moving. So again, the same idea. I'm creating here many sprites that are going to be these small stars, and in fact are also creating some big asteroids here. In this case, I'm creating a class to work on these, to wrap these asteroids with some extra functionality. That's perfectly fine. I can derive from Sprite, or don't derive from Sprite and just use Sprite as a parameter to the constructor, whatever makes sense. Or maybe the sprite is going to be part of that class, whatever makes sense. And the third component here relates to all the enemies. So we have many enemies, and I can manage their state nicely and very conveniently by having their own components. Here they are drawn, created, updated, all the collision detection is happening, and so on. Okay, so next, collisions. Now, normally you've seen that I've run the game, I'm firing and things explode, whether it's the player's ship or something else. So one of the things to see or to do is to know when things collide. So to do that, we need to know the positions of the various sprites and then do some comparison. Now, generally, this is very complex because these sprites have transparent pixels. So if you have transparent pixels, you need to sort of make sure you only check the pixels that are not transparent. But this is something which is just too slow to be practical. It is possible, but it's not really practical and usually not really needed. So typically the technique is to sort of cheat a little bit, like having a bounding box that encapsulates the object, like the player ship and the enemies and so on, and then comparing boxes. And comparing rectangles is very fast. So you can do that without any noticeable performance hit, because it could be dozens of sprites on the screen at the same time, and you have to do these collision detections, which is normally an O(n) squared kind of algorithm, unless you use some other more complex techniques, which are definitely possible. So sometimes bounding boxes are used, sometimes ellipses or circles are used. And to make things a bit better, because most sprites are not really rectangular in terms of the visible pixels, you just squash the rectangle a little bit. So you make it a bit smaller, so you get less false positives. So you need to tweak that a little bit, which is something that you need to do when you test your collision code. And in some cases, you probably have to write some specialized codes for some types of components. So I see a question here on Telegram here. So is it possible to implement complex sprite transformation with the MonoGame, like vertex or pixel shaders? The answer is yes, you definitely can do that. You can use pixel shaders. Vertex shaders don't really make any sense for a 2D game, but pixel shaders definitely work, and you can use them to create very interesting effects, like particle effects and so on. Okay, so how does collision detection work here? Here's the sprite class. There's a method here that is related to collision. It's called is colliding or something similar, is collision. And you can see it expects another sprite, so it's trying to test to see whether two sprites collide. It first makes sure that they're both visible, so they're both alive, because if they're dead, it doesn't really make any sense to make the check. And then I'm going to call a method here intersect on a bound object, which is a bounding box class that I created that knows how to do these checks. And you can see I'm shrinking the box in some percentage that is configurable, so that I don't get too many false positives because of that approximation. Okay, next, what about sound? Sound is actually very important, like I said. So you can have background music, for example, and we can have sound effects when something is hit, something explodes, and so on. And it's fairly easy to use these things. So let's see what that looks like in terms of code. So if you go back to our content, so we have assets which are actually audio assets. So for music, you typically have an MP3 file. So here's the audio. We have an MP3 file for the music. This is the background music I'm using here. In fact, I took that file from one of the samples of MonoGame because I didn't really have any nice music going around. And then for the simple effects like a hit or something like that, we can use the WAV files. So these are just added normally just by using right-click, add an existing item, and you add them normally, and of course you have to load them properly. And this is what I'm doing here in this class called audio. This is a helper static class to do some work. So to load the content, which is audio files, I can do exactly the same thing as we did previously, but this time using a different type that is passed to the load method. So here's something called sound effect. Once I have the sound effect, I can call the create instance for that effect and get a sound effect instance. So just a simple instance that manages that particular play. And all I need to do is call the play method. That's it. I can also set up the volume, which is a number between 0 and 1, where 1 is the highest and anything else is lower than that. And for playing a music, it's just as easy using a class called song which I think I put in a different class. So very easy to add sounds, you just need to get to those resources. Okay, what else? We have game statistics. So game statistics is about showing how the player is doing, what's going on in the game, like score, lives, power, whatever that may be. And so we need to write some text, perhaps. How do you do that? So one way to do that is to use sprites normally, like get all the letters that you need and numbers as bitmaps and then use them for drawing. And the other option is using something called a sprite font file. So a sprite font is a way to describe a font, and then MonoGame, the pipeline, does the heavy lifting by converting that font into the bitmaps, and then you can just use the drawString method to draw these strings as you need them. And so if we go back to the game, let me go to the player component. The player has score and lives and all these things, so we need to draw them at some point. So hopefully we have a drawString here somewhere. Okay, so maybe not here, maybe I put that in the game class. So we have, let's see if I can find that. So here's the drawStat method, in fact, and that method writes the stats using the drawString function, and the font object we load using the same mechanism as the others. So that's the basic idea. And for stats, and so just to summarize a little bit, we've seen all the major aspects of creating a game, but of course there are other aspects we need to consider, such as the game title and how game over looks like. And generally, to make a game fun is not just about the technical aspects of writing code. You have to design the game properly, have good game mechanics, and typically you're going to build a game engine. You typically want to have a game engine that provides you lots of functionality, such as the sprite class, maybe some higher level aspects of scene management, so you can have a better sort of way of creating your games and maintaining them. So lastly, we have some links for you for MonoGame, and this sample that we've seen right now is going to be available on my GitHub repository right after, or maybe an hour or two after the talk. So thank you for joining me. If you have any questions, please go ahead, or maybe I'll see you in the discussion zone.
Well, okay, thank you. Thank you so much, Pavel. I think that we have just a bit more than 1 minute for the questions, so maybe it makes sense just to share your impressions from this talk. As far as I understand, you don't have experience in talking exactly this.
I didn't do any talk about games, game programming lately. No, I haven't. First time, really.
Okay.
Okay, yeah, so that was great, really interesting, at least for me, because I have never used MonoGame, and there was plenty of useful information about the framework and about how to start, so it's great. And guys, everyone who asked questions or who want to ask questions now about this talk or about game dev at large, or just any questions to Pavel, I guess we could move to discussion zone. Pavel will move here in a couple of minutes. I will move here right after closing of the track, so it's like 5 minutes. So we'll be happy to welcome you here. Thanks everyone who attended the talk, and thanks Pavel for the talk. It was really great. I liked it.
Thank you.